So good afternoon, everyone. Hello, everyone. Dear authors and invited guests, welcome to the technical session 8E. I am Riddhi Gohel, moderator of this session. On behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you to the 9th International Conference on Information and Communication Technology for Sustainable Development, ICT4SD, Goa, India. The ninth edition of the conference is being organized in a hybrid mode. The physical event was held in yesterday in Goa, and the virtual event is being held through Zoom today and tomorrow, that is on 8th and 9th August. I hope you will enjoy the knowledgeable interactive session throughout the day. In this session, we have 10 presentation and each presenter will be given 8 minutes for the presentation and the 2 minutes for the question and answer. So on 7 minutes, I will raise a gentle reminder. There is another request to all participants that you please stay connected with us till the closing remarks. If you have any query and update, then let me know in the chat box. Just before we get started, I would like to introduce to all our chair of the session, Professor Shafi Pathan.
Yes, ma'am.
Yes. So I would like to some introduction about Professor Shafi Pathan. Is currently working as a professor in Department of Computer Science and Engineering, MIT SOE, MIT ADT University, India. He has an experience of 23 years, worked as an associate professor in Srimati Kashibai Navale College of Engineering, Pune. He is working as a technical director of Machine Math Technology, Pune, and handling project management, deployment of project and resource management. Hello, sir. I welcome you
Thank you, Riddhi,
in
ma'am.
the session as a session chair.
Thank
Yes.
you very much.
So I would like to invite our first presenter, Mohan K. Varbe, and the paper title is A Review on the Application of Cybersecurity in IoT Integrated Robotics. So Mohan, please go ahead for the presentation. Hello Mohan, are you in the meeting?
Yes, ma'am.
Yes, please start the presentation. Yes, sir. Now it is visible. Please make a full screen.
Yeah. Good morning. Good afternoon, everyone. Hello. Now I am visible.
Yes, sir. You are visible and audible too.
Yeah. Okay. Good afternoon, everyone. My paper ID is 702 and paper title is A Review on the Application of Cybersecurity Challenge IoT and Integrated Robotics. Uh, I am Mohan Varve. I am. And in my paper, my team means co-author is Pratik Verma, Swapnil Gundewar, and Amit Gurde. I am from I am on the purchasing BTech in Datta Mege Institute of Higher Education and Research, Savangi Mege, Varda. The content of presentation is introduction, literature review, application, challenges, future scope, conclusion and references. Introduction of paper is wait a minute, sorry. IoT integrated robotics describe the improvement of robotic system through IoT facilities, coordination, data sharing, and communication between robotic devices and other network systems. Robotic robots benefits for real-time data, connectivities, and cognitive decision making enabled by IoT integration. infrastructure com- component of IoT integrated robotics, including sensors and actuators, communication protocols, and processing systems, and interact with their surroundings. The robotic systems are communication with cloud-based services and other IoT devices, and also it is integrate with local servers or network, another network. IoT also robot IoT allow robot system to process and analyze large volume of data from sensor for better decision making and adaptability. IoT architectures enable remote monitoring and control, facilitating the effective management of robot system. Application including smart manufacturing and healthcare robotics. This is the literature review. This paper I refers to write the in my paper cyber security, the review on the application of cyber security in IoT integrated robotics. Applications is industry automation. In industry automation, it it is used for enhancing the manufacturing process and security of that industrial automation. In transformation, the enhancing the safety and efficiency means in that it is enhancing the safety and efficiency of that system. Medical in medical uses it, we are see the nowadays everything is advanced in that the integration of IoT is nowadays is integrated with the normal system and it is doing well. So safety of that system is more important. This safety using of the safety is provided using of cyber security, because cyber security is help to helps to uh, protect the system uh, from digital attacks and manual also. Challenges: authorization and authentication, in which the cybersecurity is major role in that the system. Consider one system in that someone have login, then IoT using of cyber security, it is analyze the user are already exist or not. The user are already exist. The cyber security are get allowed to access forward, or it is decline the access. Data privacy and integrity. The data of the user is most important, and their the secure accuracy and reliability is it also increases using the cyber security in IoT integrated robotics. Um, those also future scope. In future, we are doing most more in that field using cyber security. Cyber security are helps to cybersecurity are helps to decline the attacks, means digital attacks or manual. In it, it is increasing the safety of the system. Using nowadays, we are using 5G enabled thread. Integration of 5G system, 5G enabled threads in our existing system. It is uh, means is having lots of challenges in future. Quantum computing thread, it it is a lo- uh, Human-machine interface valuability. Interface between humans and machine in IoT system can be explored to gain authorized access or control. It is helpful for it is helpful for interaction between humans and the machine. Using of IoT, we can interact the humans conversation of humans to easily understand to the machine. And conclusion, the integration of IoT with robotics introduce significant cybersecurity challenges, including physical tapering, network security, and data privacy. Addressing this issue requires security communication protocols, preventing unauthorized data access, and fixing firewall vulnerabilities. These are references I am using write those papers. And thank you.
Hi Mohan,
Yes, sir.
I'm audible.
Yes, sir. Yes, sir.
May I know where you are studying right now?
I am studying in BTech
Acha,
third year.
third year. Which college?
Dattamegi,
Acha,
Datta,
from Acha, fine. Mohan, considering your which is about suggestion rather than question. Suggestion is that whatever the presentation you are given, that all presentation is very at the abstract level, and it tells about general fundamental things only, right?
yes,
See
sir.
that if I'm saying research, if I'm saying presentation, if I'm saying something which should belongs to me only, then it should go to the in vertical depth. Means in a specific algorithm, in a specific technology, in a specific method, that should address it. Right? So see that next time, whatever you are presenting or as a research or presentation, it should have vertical depth. Right?
That's right.
Second thing, there are various methods in cryptography, cybersecurity, and all these things, which comes under authentication, then comes authorization, then comes your confidentiality, non-repudiation. Can you tell me how using cryptographic algorithm we can go for confidentiality, and same algorithm we are using, we can go for authentication. How that can be done?
We are done in some changes in that.
Acha. Can we use the question? I will rephrase my question. Can we use same algorithm for confidentiality also and authentication?
Configurability in authentication we are used, but I don't know about something.
Okay, fine. Wish you all the best. Good presentation. Right? It is all from me.
Thank you.
Thank you, Mohan. Nice presentation.
Thank you, ma'am.
Yeah. So we have next presenter is Rani Spurti Ravindra Patil, and the paper title is Classification of Scanning Electron Microscopy Images Using Deep Learning Algorithms.
Good afternoon, everyone. Yeah,
Good afternoon.
myself, Rani Spurti Patil. I'll be presenting our work, classification of SEM images using deep learning algorithms. I'll just share my screen.
Yeah, sure.
I hope it's visible.
Yes, ma'am, it is visible.
Yeah, sure. Yeah. Co-authors are Jayalakshmi GN, V.H. Chodapur, and Vishwanath P. Palikar. So we come from the Keli Technological University, which is located in Hubli, Karnataka. So I'll take you through these contents in the presentations today. Starting from the introduction, our work goal, its implementation, which is basically done in 3 parts, and then concluding with results and discussion. Yeah. Before we begin, knowing about SEM is essential. So it basically stands for Scanning Electron Microscope, which captures the surface of the nanoparticle using a beam of electrons. Here, the nanoparticle we have considered is cobalt chromite, and based on the doping present, the sample is classified into predefined class 3 categories. Yeah. So we formulate the problem statement as to classify the SEM images of cobalt chromite sample using image processing mechanism and the traditional deep learning algorithms as well. The state of art in SEM image classification include the use of convolution neural network models. In addition, fine-tuning the model is carried out in terms of it might be the loss function or the activation functions, and sometimes with the learning rate as well. Our desire, our motivation is the desire to speed up this process, and then to improve the interpretation of the SEM images, a process that is currently labor intensive, and there are chances of human error as well. So we also aim to advance the imaging technologies for classification process. Yeah, as I already mentioned, based on the kind and concentration of doping present, the sample in the sample present, the images are divided into 3 groups. One is neodymium dope, the other one is lanthanum dope, and the other one is pure cobalt chromite. Our data set includes 93 images, the original data set, and these images are taken at different magnifications. Yeah. Coming next, these are the samples. The images pertaining to class ND, the class LA, and a class. Yeah. Looking at these images, we can observe that these images are, are challenging to classify even for humans. Unlike the other traditional data sets, wherein we can using our in our naked eye, we can easily classify to which class it belongs to. Yeah. The workflow is depicted in the figure here. We start with analyzing and sample preparation and collection of the SEM images. We got these images from the sample print from a Mumbai lab, and then we employ the deep learning models and a new classification algorithm after pre-processing these images. Further, we also, in order to enhance the breadth of our investigation, we further employ computer vision techniques to determine the surface area parameter of these particles. Yeah. We refine the collected data sets through minimizing the discrepancies. We further, sequentially divided the data set so as to augment and then increase the size of the data set, since we had just 93 images in the original data set. We also carried out a few other image processing techniques such as histogram equalization for better appearance of these images. Yeah. Yeah. We provide a unique approach which is called as low complexity algorithm, which is designed on image processing rather than the neural models. So it is intended to significantly enhance the classification accuracy. So in the low complexity algorithm, the first algorithm we have is for algorithm for extracting the 8th bit. So we have grayscale images, as we already saw, and the 8th bit plane, which is the most significant bit, contributes to the maximum for the appearance of the image. It has all the predominant features of the image. So what we do is we calculate the number of ones which are present in this particular most significant bit and then store it. Yeah, as a feature. Yeah, the second one we have is for comparing and finding the nearest match. Once we have the the features stored for every image, what we do is we, for an image in the test set, we calculate the features and then compare it with the train set, and then to find the class to which it belongs to, the to which it belongs to. More the match, more clear is the class the test image belongs to. Yeah, before we get into the results, the traditional, the classical deep learning architectures we used were CNN, VGC16, and Inception V3. to compare and then interpret our algorithm results. Yeah. Coming to the results of the CNN, for over 80 epochs, the testing accuracy was around 52%. We also have the classification report as well for each of the deep learning model. The second one is VG60, and then the same over 80 epochs, and using the learning rate of 0.001, we reached the testing accuracy of around 60%. Yeah, the Inception V3, the testing accuracy we achieved is 50%. Yeah, coming to the low complexity algorithm results, here always the the training accuracy is always 100%, as the features are already stored. And then for the test data, 18 images among the 23 were correctly classified, obtaining accuracy of 78.26%. Yeah. The table depicts the performance of the models built. Based on the accuracy achieved in testing, we can say that the low complexity algorithm outperformed other existing deep learning models. And other advantages of this low complexity algorithm is the time. It takes only one epoch. Other deep learning algorithms took around 80 epochs, wherein this one is only for single loop, and the time taken is subsequently very less. Yeah. Coming to the next part of the implementation, we have parameter determination. So what we do is we calculate the surface area of the cobalt chromite using Gaussian filter and watershed segmentation to find out the counter area. And we can see that the white portion in the left figure denotes the void, whatever is present in the nanoparticle structure. The area which is obtained in the pixels is further converted to nanometer square. It requires the information of image dimension and magnification units as well. Yeah. To conclude, we can say that the early attempts with well-known deep learning models produced only moderate results, wherein low complexity approach, whatever we designed, has enhanced the performance. Though our algorithm outperformed, it has one shortcoming, that is the possibility of losing significant image information while we extract the feature. Yeah. Lastly, as a future work, we intend to use more advanced classification algorithm, as well as a bigger data set, maybe, so as to and testing upon this algorithm for other data sets as well. Yeah, few references. Yeah, thank you.
Hello, Patil ma'am.
Yes, sir.
You are saying about image scan, isn't it?
Yes, sir.
And data set. What is the authenticity of data set? How you can say
Yes.
that data set is authenticated and validated?
So the sample, whatever we considered the cobalt comet, that is prepared in our institution itself, and then for the getting all the images at different magnification, we had sent it to the M Sprint, which is an known lab in Mumbai. So we got it from there.
Now, while giving the presentation, you say that your algorithm takes comparatively very less time, isn't it?
Yes, sir.
What is the justification for that? Why you are saying that it takes very less time?
Yes, what happens in the deep learning models? The models it goes to forward propagation and then backward propagation. It takes many number of epochs. It continuously determines the parameters using the gradient descent as well. So what happens is for every epoch, it takes a huge amount of time. Wherein our algorithm, it is only for single loops. It doesn't it doesn't come back. It doesn't get trained again. There are no parameters as such. What we do is we just extract the feature and then use that thing to classify.
Okay, but very good presentation, very good preparation.
Yes.
Wish you all the best.
Thank you, sir. Thank you.
Thank you, ma'am.
Yeah, thank you.
Yeah. The next presenter is Aditya Survey, and the paper title is Envision AI and Blockchain Transforming Disability, Employment and Entrepreneurship.
Yes. Can I share my screen?
Is my voice
Yeah,
audible?
sure, sir.
Yes.
Yes, sir.
So, good afternoon, everyone. Today I will present our research title Envision AI and Blockchain Transforming Employment and Entrepreneurship for Disabled. This work is carried out by myself, Aditya Survey, along with my colleagues Mrunmay Parkar, Naush Patil, CLJ, and under the guidance of Dr. Kumkum Saxena. And we are from Thadumal Shani College in Mumbai. Introduction. So even though the economy is growing and more jobs are available, people with disabilities often find it much harder to get job these days as compared to others. This disparity can be due to various reasons such as lack of accessibility, biases in hiring practices, or insufficient support and accommodation in workplace. As a result, people with disabilities may struggle to find employment, which affects their financial independence and overall well-being. So our platform Envision aims to solve this problem. This research project is about building a platform that helps people with disabilities find jobs, learn new skills, and sell their products or services. The goal is to create a space where they can access opportunities, improve their abilities, and participate in a marketplace which makes it easier for them to achieve their personal and professional goals. The platform features are resume maker with voice input, UDID verification for authenticity, mentoring sessions, and interview preparation practices. It uses blockchain technology for secure transactions and transparent marketplace, enabling users to pitch their business ideas to potential investors. Additionally, the platform also aligns with the goal People with Disability Act, which aims to allocate 3% of all government jobs to disabled individuals by supporting their job preparation and application process. This is the overall flowchart of the website. The website flowchart is designed to provide a comprehensive experience for users. First, user registers on the platform using their unique disability ID (UDID) issued by the Government of India. After the UDID is verified, users are logged in into the portal. Upon logging in, users are directed to the resume builder page where they can create their resume. Next, they can access the interview preparation page to train and prepare for job interviews. Following this, user can explore the job page to search for employment opportunities that match their preferences. The mentorship page allows users to schedule meetings with industry experts for guidance and advice. Additionally, the opportunities page, users can upload product ideas they wish to develop and seek funding from investors. This website serves as a complete platform offering both entrepreneurship as well as job opportunities. These are the these are the features. Uh, uh, now let's yeah. Our first feature is authentication using optical character recognition. When the user with disability wants to join the platform, they need to upload the unique disability card, UDID. Once the user uploads the UDID, the system uses a technology called optical character recognition (OCR) to read and extract text from their card. OCR works like a scanner, turning the words on the card into a digital text that the computer can understand. After the text is extracted from the system, it checks carefully to make sure that the card is real and valid. It does this by looking at the specific phrases on the card, such as unique disability ID and Government of India. These phrases help confirm that the card is authentic and issued by the government. This process helps to ensure that only legitimate people with UTID card use the platform, making it secure and trustworthy. Next feature is the job search feature. This feature acts like a super efficient job search assistant. Using web scraping, it gathers job postings from all over the internet in the domain the user mentioned. After you have found a job that interests you, the system makes it easy to go straight to the job posting on the original website. From there, you can apply to the position easily. So the third feature is resume maker. The system fetches specific details about the individuals like name, contact information, etc. directly from the database. This is done automatically, so you don't have to input the data each time manually. For other details that aren't stored in the database, such as a person's credentials, interests, hobbies, accomplishments, or work experience, this information can be entered manually. This can be done by typing it in or even using voice command. After the template is fully populated with all the necessary information, the system uses a PDF generation library. This is a tool that takes the completed template and converts it into a PDF. The PDF is then ready to download and then makes it easy to print and share their results. Then the next feature is interview preparation. The interview preparation feature helps candidates practice for interview from a behavioral perspective, enabling them to present themselves in a best possible way during the real life scenario. In this feature, a question is displayed on the screen. A question is displayed on the screen that the user can answer, appearing in form of a pop-up. The questions are generally character-oriented questions commonly asked in job interviews. While the candidate answering the question, the Har cascade face detection algorithm is used to detect faces, and deep face analyzes the facial emotions or expressions. Each frame from the video camera is passed through the framework, which uses a media pipeline as backend. By identifying facial expressions like anger, fear, happiness, etc., a good overview of the candidate's confidence can be assessed, and improvements can be suggested accordingly. For example, if a user exhibits fear, they may need to do some exercises to calm themselves down, or if they appear surprised, they should practice more questions to reduce the element of surprise. The user is given 30 seconds to answer each question, and the interview duration is 5 minutes. After the mock interview session, the candidate can study the facial emotions using graph visualization. Two types of graphs are used: bar graph and pie chart. The bar graph provides an analysis of emotions, use analysis of emotions against the timestamp, while the pie chart shows the proportion of emotion throughout the session. Additionally, the most dominant emotion is also presented in form of a report. Then the next feature is crowdfunding platform. So this feature allows the promotion of entrepreneurship and self-employment among individuals with disabilities through an innovative crowdfunding solution empowered by blockchain technology. First, the developer of the project creates a campaign with minimum investment amount and provides details about the project. Investors can select the product that they are interested in and contribute to them. When the developer needs funds to purchase certain components, they must request permission from the investors to spend their money that has been invested. The developer can only spend the money once a certain number of investors approve the request. This process prevents fraud as it ensures that the developer cannot run away with the money. Instead, the funds are stored in a smart contract and can only be spent after the investors give their permission, giving them the control over their money. Additionally, the transactions are secure once the investors approve the money in the form of cryptocurrency is directly transferred to the vendor's account. Now, in conclusion, Envision is a comprehensive platform that tackles challenges faced by disabled individuals in finding employment and pursuing entrepreneurship opportunities. It uses AI technologies like OCR and blockchain powered crowdfunding, and it offers a secure and accessible solution. The Har cascade face detection algorithm used along with the deep face ensures precise feedback in interview preparation. So this Envision has the potential to change the cultural perspective, opening the doors for a time where disabilities are not seen as obstacles and where everyone is given equal opportunity. In future scope, we plan to integrate advanced ML techniques for using sophisticated machine learning models to review and assess resumes. The model can identify key skills, experience, and qualifications from the resume and combine this with job search feature for efficient filtering of the job. Then we can use natural language processing, which is a technology that helps computer understand and analyze human language. By applying NLP to interview responses, the system can evaluate candidates' answers, identify important points, and even detect tone and sentiments, giving a better evaluation. Virtual reality (VR) can be used to create realistic interview environments where candidates can practice or even undergo interviews. This allows them to experience real-world scenarios such as problem solving on the job. These are the references that we use. And thank you. If you have any questions.
Hi, Aditya.
Hi, hello sir.
Hello. Good presentation you have given. The only thing that my concern is that if you are saying about blockchain, mostly blockchain is used for the security, isn't it? The very
Yes.
first of the security.
Yes.
What is the percentage of importance of security in your project?
Yeah, security is highly important in our project because you see investors trust the developers that they will use their money uh, efficiently. So if an investor is trusting the developer, so our platform is providing an like efficient platform where money is stored in a smart contract, and so the investors can fully be reliant on our platform because they know unless they vote and unless they give permissions to the developer, the money cannot be spent. So that's why we importance of security is highly important for our platform.
Now, Aditya, if that is the case, then probably you know that blockchain is a heavy cryptographic solution comparatively.
Yes.
You might have used a simple algorithm like AES, DES, and probably it will address your purpose, which are very computational point of view, which are very less. It is required as a resource. What is your justification for the same?
We specifically use blockchain because money transfer becomes really easy. So using wallets like MetaMask, money transfer is like very easy and the transactions are also secure. That was the first reason to use blockchain. And also blockchain is the technology of the future. So we wanted to keep up with the new technology. So that was the reason why we use blockchain instead of any other technology.
Okay, Aditya, very good presentation and good preparation. Wish you all the best.
Thank you, sir.
This is all from my end.
Thank you, Aditya. So next presenter is Shahrukh Ansari, and the paper title is Expanding the Catalog of Code Smell in Multi-Language System, Definition, Consequences, Detection, and Empirical Analysis.
Yeah, hi, good afternoon. Am I audible?
Yes, sir.
Okay, shall I share my screen? Okay, is it visible?
Yes, sir. It is visible. Please go ahead.
Okay, yeah. So this is the title of my research, expanding the catalog of code smell in multi-language systems, definition, consequences, detection, and empirical analysis. And the authors are me, Mohammad Shahrukh Ansari, and Salman Abdul Muiz, and we are from University of Hyderabad. So this will be the outline of my presentation. Like we will start with the introduction, related work, then the proposed smell and the detection techniques, threats to validity, conclusion, and then references. So the introduction, nowadays, most of the projects are developed using multiple programming languages. Like there are certain studies which shows that more than 80% of both industry and open source projects utilize 2 or more programming languages to develop that. So the motivation behind using more than one programming language is the ability to reuse existing code or harness specific programming language to implement particular features. But despite having many advantages to use multiple languages, there are certain drawbacks which it stems from the integration of code written in different languages. These drawbacks often manifest as code smells, code issues that can affect the readability, maintainability, and overall performance of the systems, and they are commonly referred as multi-language code smells. Recently, Abidi et al. Defined 6 anti-patterns. These are those anti-patterns for multi-language systems, and these are the 12 code smells which Abidi et al. Proposed in the literature. But what are our observation is the catalog of code or design smells for multi-language system is not exhaustive, and there may exist more code or design smell, and hence the catalog can be extended because this is a very new area. So we thought to explore more on the design code smells related to multi-language systems. So these are the 3 contributions in this paper. We proposed 2 new code smells for multi-language systems. We proposed the approach to detect those code smells, and we assess the existence of those code smells in open source projects. In related work, in one of the early studies, Martin Fowler defined many code smells for single language systems, and subsequent studies have explored various aspects of code smells, including their detection impact on software quality and refactoring technique. However, most of the studies have considered the source code as mono language. Recently, a few studies like Avedi et al. They conducted several studies in for anti-pattern or codismals for multi-language systems, and they particularly considered this multi-language system for JNI, Java Native Interface Systems, which uses Java and C or C++ as codes, programming languages. In one of the study, Avedi et al. Proposed detection techniques for the 15 multi-language code smells which they proposed. The observation from the related work is the catalog is not exhaustive and more code design smell can be added to it. So here we are proposing new code smells. The first code smell is language envy. It is a method level code smells. What it is it refers to a situation where a function implemented in one language interacts more frequently with functions implemented in any other language than it does its own language. Like here in example, we can see that this M1, this is the method which are implemented using language A. And these M2, M3, M4, these are the methods implemented using language B. And here we can see that M1 is calling more methods from the language B compared to the methods in language A. So the consequences are there are studies which shows that overhead associated with calling a native method. Native method is just a foreign method in JNI is approximately 3 to 5 times greater than that of calling a non-native method. Like if we call C or C method from Java, then it will take 3 to 5 times more resources than calling a Java method from Java itself. Why is this a code smell? Because this situation can lead to increased coupling between different parts of the system written in different language, making it harder to understand and maintain. While there may not be direct empirical evidence linking language envy to programming errors, the increased complexity and coupling it introduces can make it more challenging to debug and enhance the system over time. So we propose a detection rule for language envy inspired by the Lenja et al., which proposes detection rule for feature envy in single language system. And this language envy is for multi-language systems. So we define two metric. The first one is access to method in foreign language. It is the count of number of times method accesses or interacts with methods written in a different programming language. And another is LMA, locality of method access, ratio of ratio of number of local method access to the total method access. Okay, so this is the detection rule we propose that a source code is envious, means it is suffering from language envy. If the ATMFL means access to methods in foreign language is greater than few ATMFL, few ATMFL is a threshold here which can be changed according to the situation, and LMA is less than max percent LMA. Again, max percent LMA is threshold. We can change it accordingly, and taking inspiration from iPlasma analysis tool, the value of these thresholds are taken as 2 and 1/3 respectively. Okay, to assess whether this language envy occur in open source projects or not, we choose 70 open source projects from GitHub, which are developed using JNI, Java Native Interface System, which uses Java and C, C++ as a programming language, and that should have at least 10 native or foreign methods. And then we applied our detection rule on those systems, and this is the result of for language envy. This project is the name of the project, and percentage smell is the percentage of non-native methods, means the uh, 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 base language methods that calls a foreign method inside them and suffer from this language investment. The another smell is cross responsibility declaration. It is a class level code smells, and it refers to a situation when, in order to limit the classes or modules that are involved in interlanguage communication, developers try to declare new foreign language function in those classes or modules that already have foreign language functions, regardless of whether the new function matches the concern of the class or not. And this smell violates the separation of concern and single responsibility principle of a class, and this can also lead to large class code smell, which is a single language code smell. So why is this a code smell? And again, the situation can lead to classes that are harder to understand, taste, and maintain. And while there may not be empirical evidence linking it to programming errors, adhering to single responsibility principle generally leads to more maintainable and understandable code base, reducing the likelihood of errors in long run. So this is one example of cross responsibility declaration from one of the project. That here we can see that image scanner is having 8 methods, but these set config and scan images are called most of the time in main activity. So these two methods should belong in main activity class. So here we can say that the image scanner is suffering from this cross responsibility declaration smell. Okay, this is the rule for cross responsibility declaration smell. To detect this smell, we have to detect the classes that declares foreign functionality, but that functionality is being used by any other class most of the time. So here we this usage mapping FDI is the set of classes in which this foreign method FDI is called. And this CU max FDI is the class which calls this FDI most of the time. And here we are comparing the CD is the class which declares that foreign method, and CU max is the class in which that foreign method is called most of the time. If those are not equal, means that foreign method doesn't belongs to this class, and hence it is suffering from this CRD smell. To assess the occurrence of this CRD smell in open source project, we choose same open source 70 open source project which we use for language envy, and this is the result. This NONC is the number of native classes, means those classes which declares at least one foreign method, and number of native method is the number of foreign method in those classes, and percentage smell is the refers to the percentage of native classes that suffers from cross responsibility declaration as well. Here we can see that wherever the number of native classes are less and number of native methods are more, then this suffers from this smell.
Hello,
This
sorry
is,
for the interruption, sir.
yeah.
Yeah, sir, you have only 1 minute left for the presentation.
Okay, I'm concluding. These are the threats to validity. I think we have less time, we can skip this. So this is the conclusion. We propose two code smells, language enemy cross responsibility declaration, and we propose detection rules for those smells, and we assess the existence of two code smells in open source projects, and we find that 9% of non-native methods and 37% of classes with at least one native method show the cross responsibility declaration smell, confirming their occurrence in open source projects. The results indicate that the identified code smell is prevalent in open source project, underscoring the need to address these issues to enhance maintainability and performance. Future research could provide valuable insights for developers by investigating the impact of this code smell on software evolution and exploring automated refactoring strategies. These are my references. Thank you.
Hi, Shahrukh.
Yes, sir.
You have made the presentation using latex now?
Yes, sir.
Acha. You are saying that multi-language
Yeah,
platform or multi-language
multi-language code base. Yeah.
multi-language code. What can be means? Can you tell me a scenario in which case it will be very useful?
In which case?
It is very useful.
Yeah, nowadays, see, like in the projects, in many projects they use some programming language for front end, some programming language for back end.
Use
Like
case I am saying.
use case like I have used that Java native interface systems. Okay, in which C or C++ methods are used where the time bounds are very critical. Like if you want to implement a method which are very time critical, and we know that C or C++ is faster than Java, so we will implement those methods using C or C++, and we can call those methods in Java.
Acha. Can you tell me about interdependency? Means if interdependency happens there after doing it, how it is tackled?
Yeah, this there is a mechanism. This Java native interface is a foreign function interface of Java that facilitates the calling between Java and C. Java can call C, C++, and C can call Java and Java methods also. That
Acha, okay. Okay, Shahrukh. Very
okay.
good presentation.
Okay,
Very good presentation at the same time.
Okay, thank you, sir.
Wish you all good luck. That's
Okay.
all from my end.
Thank you, sir.
Yeah, thank you, Shahrukh.
Okay, thank you.
The next presenter is Gauri Nagral, and the paper title is Leveraging the Text-to-Image Generation Models for Automated Creative Processes in Corporate Marketing.
Hello, am I audible?
Yes, ma'am.
Is my screen visible?
Yes, visible, ma'am.
Good afternoon, everyone. I'm Gauri Nagral, and I'm honored to present our paper at the ICT4SD 2024 conference. My co-authors are Dr. Mrs. Sharmila Sengupta, Meera Savandesai, Kritika Yadav, and Yashraj Mulwani. And we are from Vivekanand Education Society's Institute of Technology. Starting off with the abstract, as we all know, we live in a time where business to consumer interaction is more competitive than ever. Product-based industries need to advertise their products across mediums to gain a consumer base. However, creating an advertisement takes a lot of time. This entire process can take anywhere from a few hours to several months depending on the complexity. There has been tremendous growth in technology, especially the rise of generative AI. You all might be aware about generative AI through tools like ChatGPT, which generates text upon giving prompts. However, the generative AI framework is not limited to text only, and it extends to the image and video domain. Text to image generation AI works on the same basis as ChatGPT, wherein it takes prompts and creates/generates something related to that prompt. We are going to explore how it ties into advertisement creation in this paper. We also aim to protect proprietary data. Expanding on the abstract, there are various marketing strategies fundamental to consumer engagement and driving sales. These strategies need to be optimized, and the way through this is integration of technology to automate creative processes. LLMs have been proven to be helpful in domains such as education and healthcare. In the education domain, they can create study materials, and in healthcare, it can create targeted messaging to promote public health initiatives. But also there is a certain trade-off between these expedited creation processes using technology and high-quality content that designers make. This paper discusses the development of a sophisticated Gen AI models tailored for the marketing sector. Proposed system. We have determined the end user of the system to be professional advertisement designers of a company. The requirements such as quick theme generation, idea generation, and so on are taken into account. We have also determined key elements in an advertisement such as taglines, slogans, themes, and implemented them using AI. This is the architecture of our system where the user will give a product description to our user interface, and a large language model like GPT-4 will be used to convert the product description given by the designers to convert it to a format that is understandable by the model. This section represents the model training and LoRa architecture. Also, GPT-4 will create taglines which will be overlaid on the generated image to create an advertisement. For the model training modules, images from the company website or if company has access to their internal images will be scraped. These images will be transformed and captioned. The images will then be injected with noise and the diffusion model will be trained to predict the noise, thus creating a new image during the process. We have made use of AWS SageMaker Studio Lab to train and test our model, which provides high-end GPUs through cloud. ngrok client server and architecture is used to communicate with the website and used for communication between the website and the AWS Jupyter Lab interface. One second. Methodology. We begin our methodology by evaluating various text-to-image generation models. The highlighted models include DALL-E and Imagen. However, due to the high cost and paid access of these advanced models, we shifted our focus into accessible options such as DeepDays, Dreamboot, StyleGAN, SNGAN, and LoRa, each with their unique capabilities and constraints. DeepDays was inspired by Google's Deep Dream paper, which combines clip and siren for image generation. StyleGAN is known for its styling control, however, it is limited in only performing well with human faces. The metrics to score such models are clip score, FFHQ score, FID score, inception score, which focus on various aspects of the generated image to determine its quality. Stable diffusion with LoRa stands out for its efficient fine-tuning with impressive scores across all metrics with clip score range of 34.91 to 36.21 and a clip directional similarity of 0.079. LoRa also provides a private environment for proprietary datasets. Number of images and captions will depend upon the complexity of the product. These are some captioning insights that we gathered, where if you caption without activation tags, challenges emerged in generating images with nuanced environmental context. Therefore, we concluded that activation tags are necessary in the captioning process. Short-length captions perfectly captured the prompt and generated images accordingly. However, long-length captions, the model had challenges maintaining the object's prominence in the generated images. These 7 color-coded models represent different sets of hyperparameters, and this loss to epoch graph indicates how different parameters play into the model training. All the models plateau after 1,300 steps. Automatic 111 Web UI provides various testing/generation parameters such as XYZ plots and SR metrics. We tested metrics such as classifier-free guidance scale and sampling steps against each other and found that CFG scale exceeding 7 generated random artifacts in the image, and sampling steps beyond a certain point just consumed a lot of time but did not generate a better image. Sampling methods used different amounts and sequences of denoising steps to convert a completely random image in the latent space to a coherent and clean image. We tested various sampling methods such as Euler, DDIM, DPM2 Keras, and DPM++2M SD exponential, and we found that Euler and DPM Keras fit the best with our dataset. The domain of advertising transcends mere product description. For example, mere representation of a shampoo bottle may not yield the same consumer engagement as an image that integrates bottle with a narrative context, such as being utilized by an individual with aesthetically pleasing hair. This distinction underscores the imperative for advertisements to not only showcase the product, but to also encapsulate a story that aligns with the brand, such as the bottle can be paired such as the bottle can be paired with another product, for example, a lunchbox or with a famous actor. We have determined a method called associative generation, which deploys and uses multiple LoRa models and combines them to create a cohesive image. The combination can be created using additional networks where specific models can be applied to specific regions of an image through mask images, specifically RGB mask images, which represent three channels to represent three images. MLNet provides control generation by providing a blueprint for the model to work on. Crafting taglines inspired by the company's previous ad campaigns can be done by using GPT-4 or Llama. These taglines are then integrated into the generated image using OpenCV by segmenting the image to create an RGB mask and by overlaying the tagline onto the image area contour. As we can see in the figure, this would be the final output. And here we gauge what the designer wants through questionnaires, where designer can answer basic questions like what background setting would you like and so on. Conclusion. This innovative platform streamlines ad production by merging automation with customization, enhancing efficiency and quality of advertisements while maintaining brand integrity. Its advanced architecture not only boosts user creativity, but also allows business to stand out in the competitive market. Prospects for the system involve continuous innovation of advertising strategies using this technology. Thank you, everyone.
Hi, Gauri.
Hello, sir.
You are saying about text to image generation, isn't it?
Yes, sir.
What is validity? How you are validating that the correct image is generated?
So we use techniques like FFHQ score, FID score, where we have, so for example, inception score is a metric where the quality can be measured by calculating the KL divergence between the conditional label distribution and the marginal label distribution. So basically it classifies like in the image, it classifies how correctly all the objects are present in an image, and it also uses multivariate Gaussians to calculate the score.
Acha. It's okay. As far as topic is concerned, it is good, but there are many tools available in the market which works on these techniques, and especially they are integrating AI. They are integrated with the AI to produce a good result. I hope that that comparative analysis may be there with you, right? So
Okay,
it is all from my end. Thank you.
thank you, sir.
So our next presenter is Akanksha Jain, and the paper title is Multi-Noise Classification in Image Using Fast and Fourier Transform and Power Spectrum Density.
My voice is audible?
Yes, ma'am.
Yes, it is.
Okay.
Hello, Jain sir.
My screen is visible or not?
Yes, ma'am.
Okay. Hello, good afternoon to respected sir and dear colleagues. Myself Akansha Jain, and I am doing my PhD in from GLS University Ahmedabad. My paper ID is 338, and my topic is multi-noise classification in images using fast Fourier transform and power spectrum density. As we know, image noise classification is a critical aspect of image processing and computer vision, with various application fields like image restoration, art preservation, art restoration, photography, then remote sensing, etc. So this is the agenda which I will cover today's presentation. I use mainly three individual type of noises and one mixed type of noises. This is the one type of original image which I picked from one data set. First noise type is Gaussian blur type of noise. In this type of noise is uh, created by changing of pixels up and smoothly up and down. Uh, the second type of noise is impulse blur type of noise. This type of noise can introduce like irregular spikes in random position, which are the white and black pixels in the particular frequency domain. Third noise type is the motion blur type of noise. It occurs the relative movement of subject and camera. And I created one more type of noise, which is a mixed type of noise. It is a combination of Gaussian impulse and motion type of noise. So I use some pristine images from two different data set, which is a CADIC 10K data set and BHD 100 data set. These are the sample images of this data set, and this is the different noise variation of CADIC 10K data set and uh, BHD 100 data set, which represent the original Gaussian impulse motion and mixed type of noise images. This is the workflow of current methodology. First one is the load and pre-processed data. Firstly, I convert a particular image into 224 by 224 pixels. Images are by default in spatial domain. For finding the variation of different frequency, I converted particular spatial type of domain images into frequency type of domain images. I use two type of frequency methods, which are the FFT and PhD fast Fourier transform and PhD power spectrum density methodology. Using this type of methodology to obtain magnitude spectrum of different type of noises, how the noises vary from particular type of noise, like for Gaussian type of noise, for impulse type of noise, for uh, motion type of noise, and for mixed type of noise. Then compute statistical parameter for each type of images for image magnitude spectrum. Then extract feature from images using these magnitude spectrum, how edges are vary from particular noise, how different image attributes, image values are vary. uh, then categorize different type of noise based on particular mean magnitude values. Then one classification method is used for research purpose, which is the random forest classifier, uh, using power spectrum density features and fast Fourier transform magnitude statistics. Then use a trained classifier to predict different type of noises in particular test images. And one accuracy parameter is used for finding the particular correct prediction for both two methodology, which are the FFT and PhD features. FFT only measures for frequency and phases, like spectrum density, uses for particular power of images, particular power of intensity of particular images. Then training and testing of images. I use 500 training images from KDIC 10K dataset and 600 images from BHD 100 dataset. And for testing purpose, 70 images are carried out for particular dataset. This is the performance evaluation criteria which I use for finding correct predictions. It is denoted by correct prediction divided by total predictions. So this is the result. Uh, for this, I use mainly four type of noise with along to original type of noise. Apply table 1 denotes the accuracy outcome of KDIC 10K dataset, as well as table 2 denotes for accuracy outcome of BHD dataset. Uh, I applied equally number of images for both dataset. In this result, PhD power spectrum density gives a higher accuracy for original, Gaussian, motion, and mixed type of noises, while FFT fast Fourier transform gives the highest accuracy in impulse type of noises. So we can use particular methodology for different type of noises. If impulse noise are available in particular image, then use FFT. Or if Gaussian, motion, and mixed type of noises are available in a particular images, then we can use power spectrum density for the image noise classification and then denoising of particular images. This one is the conclusion and future work. We can use different methodology as per the noise classification of images. Uh, in this research, PhD methodology, power spectrum density methodology gives the better result, and will work on identify different more type of noises from particular images, and then apply different type of filtering according to identification of noise, and then denoise it. So these are the references which I use for this research purpose. Thank you, sir.
एक minute, sir. Hi, Akanksha.
Hello, sir.
Acha. In classification method, as you are doing classification, you are saying, isn't it?
Yes, yes,
What are
sir.
the different classes it is producing?
What, sir?
List of classes it is producing. How it is classified?
Sir, it identify the different frequency variation of particular type of noise, like a Gaussian, like particular Gaussian type of images. It identify the pattern of frequency. For same way for impulse, for motion, and for mixed type of noises, and use particular statistical measurement, and then apply random forest classifier to identification of this magnitude spectrum.
Acha. Fine. What will be the application domain of this?
Application domain like security and surveillance, medical imaging, then photography, then art, historical paintings, art restoration and preservation. So these are the normal application we can use for noise classification, and identify particular noise. We can denoise. We can apply the proper filtering, proper methodology.
Acha. Okay. Good presentation, Akanksha. It is all
Thank
from
you,
my
sir.
end.
Thank you, sir.
Thank you, Akanksha.
Thank you,
Nice
ma'am.
presentation. So we have next presenter is Deepak Mane, and the paper title is Potato Plant Leaf Disease Detection Using Customized Deep Learning. Hello, sir. Are you in the meeting? I think he is absent.
Okay, Riddhi.
Yes, sir. So our next presenter is P. Ramakrishna, and the paper title is Systematic Access for Layer 7 Attacks and Mitigation. Mitigation.
Yeah, good afternoon, sir. Good afternoon, all.
Good afternoon, sir.
I'm sharing my screen. Hope.
Okay, sir.
Hope you're able to see my screen.
Yes, sir.
So myself is Ram Krishna. I have done my PhD in cybersecurity. I'm working as a solution director, and from last couple of years, we are trying to integrate artificial intelligence to our products. Actually, as part of it, I'm doing some research. This is one of that actually. Like as of now, the layer seven application or layer 7 attacks happens, and firewalls or snots will detect actually. So if you the idea here is like actually to integrate the AI methods like behavior analysis or forecasting sort of stuff and making them to detect in a better way. That is the idea of this paper and the research. So basically, if you take application layers, right, we used to hear like a data sort of attacks used to happen at a long time back, but actually now it is taking a new turn with the emerging of the botnet technologies and bot and ransomware. All these things actually coming in. It is taking a big turn actually. With the botnet is something actually a bot master will inject an initial bot to some of the systems and see the security. If they are vulnerable, right, he will inject the second phase, so he will try to take control of some of the activities that are happening in the specific system, and he will try to inject some sort of attacks there actually. So with that actually they will have an access to a large scale attackers actually. If you are able to crack some sort of a cloud systems or like a big environment systems, they can bombard the network with a lot of traffic and they can bring down the resources actually. So if you take the recent attacks that are happening is like a DNS amplification, Facebook sort of stuff went down, or like HTTP post get a request actually. That is where actually UK based servers, banking servers went down. These sort of attacks is happening very common nowadays actually. So if you take that application layer DDoS attacks, right, the main objective of these attacks is they will be focusing on two things. One is like the entire network bandwidth. They will try to do a congestion actually. So something like actually if they get an access to a specific client or something, right, or a group of clients, what they will do is like they will just change the DNS poll time. It is a simple configuration sort of stuff. So what happens is like that client will request for the DNS request very randomly. Similarly, like NTP or something, which is a commonly used and very frequent stuff sort of stuff they will do. That will create a lot of a bandwidth congestion in the network. The other one is something like a resource depletion on the actual servers or the firewalls. Say something they will play with some sort of a, protocol level vulnerability, something like they will try to make it see like what was the maximum capacity a SIP cache can do, or like when it will overflow, or like actually if you are doing some sort of a same ID, if they're sending some similar request, right, what is the depth it can go, which it can cause high CPU or like sort of stuff. They will try to see and they will intimate those attacks actually. So the recent surveys like 2022 till that we are seeing like still DDoS with application DDoS is having a major role here. So this is for the Cloudflare data. So we have taken that, and as part of the case study, we try to implement some of the these sort of DDoS attacks that are happening or can happen actually. So basically, this is something like an HTTP post attack, where actually what happens is like actually bot will take a control of multiple systems in the network, and they will tell that actually we want to transfer a big file. Okay, they will tell like they want to transfer a file of 1,000 bytes or something. So up to that everything will happen in a smoother way. So because it is a genuine system, it will do in the moment the connection happened, right, this guy will come and inject one connection request, HTTP post request, saying that I want to transfer a big file. When that is happening, right, server thinks that all authentication was done and it will allow it actually. So the moment it allowed, right, what it will do, it will not transfer the data at one stretch. It will transfer at a very slow rate. So if it is happening with one system, it is okay, but a multiple systems reserving like 1,000 bytes of data or something, and actually that server will go down. Okay, so with this experiment, actually we are able to make our local Apache servers are down within few seconds actually. So the existing mitigation for them is actually per host level or something, making some sort of a rate limit limiting, or like at a user level maintaining a rate limiting sort of stuff was existing. Okay, and this is what we have done it. Actually, we will generate we will make a genuine connection in between. Actually, we will generate a content length I want to transfer very long. Like that, I will make it with multiple hosts or multiple HTTP hosts, so that the actual server, right, the HTTP server which goes down with this sort of a scenario. Another one is like actually like TCP level, right? We can do a sin act sort of stuff. Similarly, at an application level also, we'll be doing an handshake. Okay, so with using this, right, actually what the bots will do is like actually they will spoof the IP of an important systems in the network. Actually, let us take a firewall or or a specific server or something. They will spoof that packets and they will send the SYN to the actual server. So the moment the SYN or SYN acts are coming, right, it will not come to the guy who generated it. It will go to the guy actually who is actually a victim, and he don't know what to do it actually. So with that, right, actually they are going to make the system skill. This is something like resource sort of usage sort of stuff actually. So to detect that, right, actually we will be using SYN cookies, or firewalls will do some sort of an embryonic connections, and then only they will allow. So these are the existing mitigation methods that are used to overcome this. Similar, this is also like in our local labs, we have recreated this in-flight sort of attack, where actually we will be sending with a SIP we used actually, and HTTP we used. We are able to recreate it, and we are able to bring down the specific requested servers actually. So, the other one is like a DNS amplification attack. This is the most of the application layers, they will target our DNS or NTP usually actually. So what it will do, what attack we have created here is actually, so whenever the bots, what they will do, they will try to generate a DNS request, and they will try to see like actually how much responses are coming. Okay, let us take Amazon. It may result into some 100, or Google.com, it result into 200 or something like that. So they will try to generate a small request, but they will identify which is giving a large data. The moment large IPs or a large set of data need to be given, right, what they will do, the DNS server will do, it will turn to UDP from TCP, which is actually a fishy thing, and then actually they will be sending a large data set up continuously. So this information, once they got it, right, they will send this to a multiple systems which are part of the bot, and they can generate this attack in a larger way. So currently actually there is something called DNS resolvers will be there. They will periodically pro or like a rate limiting. So these are the existing methodologies that are existing actually. So this is also like amplification attack we have recreated in our local labs, and we are able to make the bandwidth of the network or something clumsy. So what is our idea, or what is our methodology is like, this is how the network look like actually. We will be having a service providers, and we will be having a firewall, and we will be having external network here. So we want to integrate one system to the firewall, which is called as a behavioral analysis system. So that guy will try to see what is the generic behavior of the user actually. So and it will record it. So the moment there is any deviation or something is happening from that, right, it will generate an anomaly to the firewall. The moment anomaly comes, right, for those specific users, we are going to trigger an authentication by different means, and we'll try to identify whether he is a genuine guy, that IP is really existing, or and whatever the browser or application is working, it is a genuine or not. Okay, so those sort of things that what we are trying to achieve as part of this research. So basically that behavioral analysis we will do by using ML methods, and that I will go through it actually. So basically, as part of the first step actually, the system is going to sit behind a firewall or it's not. It is going to track the user data. Okay, something like actually how many, let us take a top contenders, 1,000 contenders or something. What is the request rate they are doing actually? What is the packets per second they will send? What was the like number of connections? What is the ideal time of it? What was the like what was actually type of files they will transfer, or like what was the protocols they are using? All this data we are going to keep it actually. Okay, and the moment we keep this data, then we will make some benchmarks based upon geographical locations and based upon the time usages, because like office hours it will be different like that actually. We are going to make a different benchmarks, and make a time series of data. Okay, from that actually we will make that as a first thing, and then what we're going to do is like actually generally these attacks will happen at a group level to make it actually. So we will try to monitor the per host as well as per group actually. Okay, so we will try to see like per host, like what was his usual rate, and is anything is going wrong there. Okay, and similarly like as a group of systems, right, something, right, what was the normal thing and what it is going. Okay, so there we are using some sort of a cluster methods for unsupervised, like k-means or historical means we are using for different parameters. Let us take packets per second or like protocols per second. So it needs if, k-means, if you know that the number or something in advance, right, we can use for those things. Actually we are using like these are the protocols we know. So there will be something we cannot predict. Okay, something like actually the flows coming per second or something. There we are using hierarchical sort of a clustering. Once that is done, actually we are applying, we are collecting the normal data as well as like a threshold data with based on the time frames, and we are applying them to the isolation forest and random forest. Again, for each parameter there might be a difference. Actually, when we need a supervised sort of a learning sort of stuff and unsupervised, right? So we are going for a random forest. Such sort of stuff we are doing, and we are identifying it actually. So as part of our local experiment, we have kept it in a local firewall in our networks, and we have collected a periodic data. And from there, actually we are trying to make it like actually we experimented with the different algorithms for making anomaly, and from our results, actually isolation is looking somewhat better, and based upon that we are able to detect it. So this is the data that is coming from a firewall, actually, like a different host and all this information, how many, what was the CPU that it is going on, and blocks that are going on. And from that, actually we are trying to recreate an issue that is where the issue is something like the memory will go down. Okay, this is the blocks or a memory, those will be going down. Okay, this is the symptom. The moment this is symptom is coming, we need to mark it as anomaly and need to do the further process. So this is something like actually this is where we are we are making this anomaly detections there. Once we made the anomaly detection, this information or the list of hosts that are actually causing the problem, right, will be given to the firewall. The firewall has its own methods actually. Let us take, if it is an HTTP sort of communication or something, it can challenge like a captcha puzzles, what we will see in our general usage, or like a JavaScript like authentications, right? Actually it will be as part of initial negotiations, they will be giving a token, and it will re-challenge. Actually it need to give back the same token, or like actually all of a sudden, actually the moment it identifies like actually it was something attack or something, it will redirect the URL. HTTP redirect will do, and again cookie authentication will be triggered. Again that guy, you need to do it actually. So these are the different authentication methods we are trying to do and validate whether that guy is a specific guy is actually a real genuine user, or it is something like a bot or like some program that is doing it actually. The moment it was done, right, those IP addresses, if the responses are coming fine, actually we are going to make it like a genuine, and again we are going to give back to the system to observe it furthermore. And if it is not, like we are going to the fade it, the firewall is going to make some sort of a shun list, block list, sort of stuff. Those IPs are those users, right, they will be blocked for further communication. Okay, so see, basically we implemented, we are, this is a part of our solution. We are trying to do some sort of a future forecasting of the user, how he will behave, or like we are trying to see the behavior analysis. This we are going to club as part of our future study, future things we are going to club to the existing firewalls or Cisco and HCL related, and we want to see like how this is going to make it as a next generation security analytic engine actually. That's all I have on my side.
Hi, Raman.
Hi sir.
Basically, as far as network security is concerned, AI will going to play important role. Although AI is not penetrated so much in information security domain, but eventually it will come and it will do. One of the in one of slide you have shown that traffic from one level to come down to another level means it lowers, isn't it? This slide lowers.
Yeah, correct. So
So,
the thing is, yeah, go ahead
so
sir.
how you can justify that lowering a traffic can be a attack?
Yeah, we are not justifying that as an attack. Actually, we are going to make like what is his normal usage. Okay, let us take, actually he is using at any point of time, let us take these blocks or something, right? It is coming between the 4K level. Okay, the moment it is coming below 4K level, then we are thinking there is something is going wrong here, there is some fishy is going wrong here. This at this time, actually this was his usual usage. So the moment it is coming along, we are going to indicate to the firewall, boss, this is the specific host, and he is using a lot of memory now. And what we need to identify, like what is going fishy. So then actually to instead of checking everybody, so So who actually making this specific stuff, right? For that, we are trying to do some sort of second level authentications to ensure that things are fine.
Acha. But if you see that all this is happening either at the network layer or data or physical layer, isn't it?
It is happens, this firewall sits at we are going to make the system into sit next to the firewall, sir. So the firewall is going to apply for all up to layer 7, because he will be the first thing, he will inspect and he will send. So this firewall is used to have a statistics till layer 7, sir. That is the reason we are trying to integrate at firewall level rather than at a host level or servers levels.
Whatever you have covered, it is a huge topic. That is good, and practical implementation is there, practical applicability is there. So it is good. It is all from my end. Wish you all the best, Ram.
Thank you.
Thank you, sir, for the presentation. Moving our next presenter, Vyom Agrawal, and the paper title is Unnamed Aerial Vehicles for High Altitude Human Detection, a Review and Prospects.
Am I audible?
Yes, sir. Please go ahead with presentation.
Good afternoon, everyone. My paper ID is 141, and my paper title is Unmanned Aerial Vehicles for High Altitude Human Detection, a Review and Prospects. Unmanned aerial vehicles, commonly known as drones, have rapidly advanced in recent years, becoming essential tools for various applications, including surveillance, research, and rescue, and environmental monitoring, and many more. So this paper focuses on utilizing of UAVs for high altitude human detection, an area that is gaining attention due to its critical application in military operation, disaster response, and other humanitarian efforts. The capability of UAV to operate in challenging environment and at high altitude presents unique opportunities and challenges for human detection, particularly in terms of sensor accuracy, data processing, and environmental factors. Research background. The increasing demand for high altitude human detection system has led to significant advancement in UAV technology, particularly in development of sensor communication systems and autonomous navigation. Previous research has explored various methods for human detection using UAVs, employing a range of technologies such as thermal imaging, optical sensors, and radar systems. Despite these advancements, challenges remain in achieving reliable detection at high altitudes, especially in cases where weather conditions are complex and difficult to navigate through. Current challenges. Current UAV-based human detection system face limitations in sensor accuracy, data processing speed, and environmental adaptability. There is a lack of comprehensive studies that integrate multi-sensors data and advanced machine learning algorithms to improve detection accuracy under varying environmental conditions. Existing research often does not address the specific challenges of high altitude operations, such as reduced visibility, harsh weather, and the impact of altitude on UV performance. Need of study. Addressing the identified research gaps is crucial for enhancing the effectiveness of UAVs in high altitude human detection, which is direct implications for military, research, and disaster management operations. Improved UAV detection systems could significantly increase the success rate of search and rescue missions, particularly in remote and inaccessible areas. The study aims to contribute to development of more reliable and efficient UAV systems capable of operating effectively at high altitude and under challenging conditions. The objective. The primary objective of this research is to review the current state of UAV technology for high altitude human detection, identifying the strengths and weaknesses of existing system. The study aims to propose potential improvement in sensor technology, data processing algorithms, and UAV operation strategies to enhance detection capabilities. Another objective is to provide recommendations for future research and development in the field. emphasizing the need for integrated multi-sensor approaches and application of AI techniques. Significance of research, search and rescue. UAVs can quickly locate survivors in disaster
The basic
areas
idea
like
is like actually where we are trying to bring some sort of like a system at
yes, sir.
here. The idea is actually to bring some sort of like artificial intelligence or ML techniques and that to tie up with some of the existing products like a firewall or a SNOT actually. So basically here as part of this research, we have taken behavioral analysis as one of the thing actually. So basically if you by using AI ML, right, we can do some sort of a forecasting as well as like you can identify what is the behavior of a user. So based upon that, right, actually, if there is any deviation, that is where what we call it as anomaly is happening, to identify that anomaly by using this new module called a behavior analysis and try to do a forecasting, okay, with this behavior, what he is going to do. So with those two, that information will be given to the existing systems like a firewall sort of stuff, where it can challenge the specific user and try to see like what is the authenticity of it actually. That was the main idea of
Hello.
Yes, Vyom, please go with the presentation. No.
Okay. Significance of research. Search and rescue. UAVs can quickly locate survivors in disaster areas like earthquakes or floods. Security and surveillance. They enhance law enforcement, border monitoring, and urban surveillance. Wildlife and industrial safety. UAVs help in wildlife conservation and ensure safety in hazardous work environments. Emergency response. They aid in planning and executing evacuations during emergencies. Uh, Software implementation, dataset creation. We collected around 4,821 images that emphasized disaster scenarios and meticulously annotated them, following the YOLO V8 standards for accurate human and object detection. Data preprocessing and augmentation. The images were standardized to a size of 640 by 640 in dimension, with augmentations like horizontal flips and random cropping to simulate very varied disaster perspectives, enhancing model robustness. Post-processing and communication. Post-processing techniques refine data detection accuracy. Hardware implementation, drone construction. We used a GPS-enabled drone, and we built it using a SpeeDB F405 flight controller, 50 amps electronic speed controller, and a GPS module, focusing on precise navigation and position hold and altitude control. Hardware and software setup. Components were assembled, including uh, motors, propellers, and power distribution board, followed by configuring the flight controller with a beta flight configurator to enable GPS and other functionalities. Testing and calibration. The drone underwent test flights to assess GPS navigation, waypoint accuracy, calibration of sensors, and PID settings were ensured for a stable and precise flights. Safety and flight tuning. Safety protocols were followed, including flight configuring failure safes and conducting test flights in controlled environments to ensure safe operation. If I have your permission, I have a video for the implementation as well.
Okay from my end.
So here we attached all the peripherals to our drone, and using the YOLO V8 model, we autonomously autonomously sent our drone through waypoints to check if there are humans present or not. So as when you see that if the drone sees a human, it using the machine learning model algorithm, it detects humans and marks its location on the map. We can also see its confidence level as well being marked. And on the right hand scan, you see that the drone is not controlled by me. It is flown autonomously. Conclusion: UAVs have significant potential for high altitude human detection, but there are still challenges to be addressed, particularly in terms of sensor accuracy, data processing, and environmental adaptability. The research underscores the need for continued development in UAV technology, particularly in integrating advanced sensors and machine learning algorithms to enhance detection capabilities. Future work should focus on developing more robust and adaptable UAV systems capable of operating effectively in wide range of environmental conditions to meet the growing demands of military, rescue, and humanitarian operations. The paper had a total of 24 references. Thank you. That's it from my side.
Hi, Vyom.
Hello, sir.
You are saying that mostly your part, that's fine. Capturing image is one of the part of your presentation or your research work. And second, analysis of image is the second part of your research work, isn't it?
Yes, sir.
So in analysis of the image, you tested for its accuracy?
Yes, sir. We use the MAP50 value that YOLO V8 standardizes in.
So how much accuracy did it
So it would on the dataset that we used, we came to around 88 till 90. Like it would vary depending on the images that we used.
Acha. And what is about distance of your camera or your drone from ground? Is there any constraint for that things?
So those constraints are dependent on monetary, like the equipment that we used. The equipment that we currently use were all built by us, so it has a limitation in meters only, like around 100 or 200 meters. The drone can fly till like 700 or 800 meters, but the equipment that we had that constraint. Current technology does allow us to go in kilometers though.
What is the configuration of camera?
So it was an ESP32 camera, sir.
It is the number. I'm saying about configuration.
So are you asking in terms of megapixel?
Megapixel, focal length. There are many parameters for this.
Sir, I think around 1.2 megapixel or something, because it's a very friendly chip, like for data transmission.
What is the cost of that camera?
Sir, around 200 rupees.
Fine. It is all from my end. Good work.
Hello.
Thank you, sir.
Thank you, Vyom, for the presentation. Our next presenter is Ishan Rai Agrawal, and the paper title is Virtual Question Answering Vehicle to Vehicle Security.
Hello, ma'am. Am I audible?
Yes, sir, you are audible. Please go ahead.
I'm sharing my screen. Good afternoon, everyone on the panel. I am Ishan Rai Agarwal, and today I will be presenting my research paper on the topic Visual Question Answering Vehicle to Vehicle Security. I will be guiding you through the key points using the presentation I have shared. So, in light of the increasing number of road accidents, which tragically result in numerous fatalities, there is growing need for innovative safety solutions. One such approach is the integration of VQA, Vehicle to Vehicle Security Model, into advanced vehicles. By utilizing sensors as well as front and rear cameras, this model aims to significantly reduce the number of accidents. Our primary goal with this model is to enhance road safety. We have developed a multi-model architecture that leverages a custom dataset alongside pre-trained model like BERT and VIT. Given the constraints of our dataset size, the use of pre-trained model was a bit necessary for us. Here's the architecture for the model. The first architecture we used was the BERT, bidirectional encoder representation from transformers. This is employed to extract textual information from the data through input sequences making it highly effective for NLP applications. It consists of multiple transformer layers, each incorporating a feed-forward neural network and self-attention mechanisms, which enable it to derive valuable insights from textual data. There is the vision transformer architecture. It is used to process visual data by dividing images into patches and embedding each patch linearly, which facilitates the extraction of contextual information. The model is particularly well suited for smaller datasets. Here are the images for the BERT and the VIT architectures, as explained earlier. So my methodology is here to efficiently integrate visual and textual information. The outputs from the visual and textual branches are either concatenated or merged using attention mechanism. The fusion process allows the model to synchronize the relevant visual and textual elements, enabling it to make well-informed decisions when responding to given queries. Here's the example of the dataset I've used. So you can see there's an image and there are questions related to the image. The first question is there any vehicle in the front? As you can see, there's a vehicle, so the answer should be yes. Is there any stop sign in front of me? If there is a stop sign, so the answer should be yes. Is there any person crossing on the road? So no one is crossing the road, hence the answer should be no. And what is the sign present in the scene? The sign present is a stop sign, so it should answer the stop sign. Here's the equation I have used for the feed-forward neural network, which is used in both BERT and VIT. A feed-forward neural network is one of the fundamental types of artificial intelligent neural networks widely used in machine learning and deep learning. It consists of multiple layers or neurons that process input data and produce an output. However, BERT and VIT do not rely on conventional multilayer perceptron. Instead, they are composed of several transformer layers, each incorporating feed-forward neural network and self-attention mechanisms. Each transformer layer, the feed-forward neural network typically consists of two linear layers, also known as fully connected layers, separated by a ReLU activation function. The equation for the feed-forward neural network is here in the screen. In this equation, X represents the input to the feed-forward neural network within the transformer layer. Weight matrices W1 and W2 represent the parameters of the first and second linear layers, respectively. B1 and B2 are the bias vectors associated with each layer. The ReLU function of the rectified linear unit activation function is applied between the two layers. This structure resembles a small multi-layer perceptron embedded within each transformer layer of the BERT model. So the results which I got with these models after integrating my dataset, I used a dataset with 400 images from the MS COCO dataset, and the textual data was around 4 questions for each image, which concluded around 1600 tech questions. So integrating AI architectures like VIT and BERT significantly enhances the security and reliability of V2V communication systems. The AI-powered VQA system outperformed previous solutions in understanding and responding security-related queries. Evaluation metrics, including accuracy loss and F1 score, we employed with the proposed architecture, achieving an overall accuracy of 94.2% and a macro F1 score of 95.5%. The system demonstrated strong comprehension of both textual and visual inputs with a Wu-Palmer score of 0.89, indicating a high level of accuracy in matching responses to questions, even when phrasing varied slightly. This approach offers a promising direction for improving the safety and effectiveness of vehicle-to-vehicle communication system. Here are some examples of the output when I ran the model. So as you can see, the accuracy accordingly. Each of the 4 scenarios in the image is composed of content-related questions. After analyzing the scene, a visual question answering system returns responses. In a variety of road conditions, the system accurately detects the existence of or absence of cars, pedestrians, and stop signs. These are the graphs of the results. In conclusion, the integration of BERT and VIT models enhances predictive accuracy and strengthens the system's ability to analyze complex multimodal inputs in V2V security. The AI-powered VQ system demonstrated significantly improvements in accuracy, efficiency, real-time threat processing. Looking ahead, future directions include optimizing the model for speed and processing capacity, expanding threat databases for more accurate forecasting, exploring collaborative AI networks for collective learning, and establishing regularity frameworks for V2V cybersecurity standards. This research contributes to the ongoing efforts to secure V2V communication system, paving the way for a future where vehicles can communicate safely and effectively, ultimately enhancing road safety and efficiency. There's a few references which have used in my research paper. Total, there are around 16 references. Thank you for your time and attention today. It has been a privilege to present my research on visual question answering in vehicle-to-vehicle security. I sincerely appreciate the insightful feedback.
Hi, Ishan.
Hello, sir.
Are there any protocol which is being used for vehicle-to-vehicle security right now?
Sir, no, they are not. But sir, they are used in self-driving cars right now, but they are not very efficient right now. Like we have used this BERT and VIT model, which is not being used right now. So this is a unique model, we can say. And so we had to make our own data sets as there is no data set available.
Achha. No, but what do you think? In the future, it will play a role. Vehicle-to-vehicle security will be important according to you.
Sure, sir. I think it will play a role as the road accidents are increasing daily, and in India there are a lot of cases daily which are reported. And I guess with the advanced technology in cars, I guess this is just an addition to the technology.
But you are saying about autonomous vehicle, isn't it?
No, sir. It can basically we will use the cameras and sensors in the car, right? So it can be in any car, like the self-driving cars or any autonomous vehicle.
So if that is the case, then there was a need of this vehicle-to-vehicle security from early age of inception, isn't it? Or when IoT came into the existence at that time, there was a requirement of vehicle-to-vehicle security, isn't it? Now, if that is the case, what are the advancement done in this area? You're getting what I'm saying?
Yes, sir. I think, sir, the advancements are, sir, like we are there, but sir, in countries like USA, there are self-driving cars in which we can see this kind of technology. But sir, like in India, it is not still there.
Right. Fine. Good work, Ishan. Wish you all the best.
Yes, sir. Thank you so much.
Thank you, Ishan. Nice presentation. So, at the last presentation of this session, Deepak Mane, and the paper title is Potato Plant Leaf Disease Detecting Using Customized Deep Learning.
Good afternoon, everyone. I'm Kailash Padman. So I will be presenting on the behalf of Dr. Deepak Mane today. So our paper title ID is 714. Our paper title is Potato Leaf Disease Detection Using Customized Deep Learning. And these are the following authors. So introduction, since farming is mainstream of our Indian economy, 67% of agriculture contributes to our Indian economy. Plant leaf disease detection mainly focuses of detecting leaf plants, health of leaf plants and diseases so that, to avoid any further losses or damages to farmers. And to detect them in an early stages is a very tedious task. So our primary objective is to collect and prepare a large data set for the Indian potato plant and implement a deep learning model. So this is the related existing work in today's world. So based on these papers, we have used our own customized deep learning approach using CNN, and we have achieved an accuracy of 96.97. And this is our proposed architecture. So we have collected data from various potato leaf plants. We pre-processed it, split it, and put it into model training. Then after training the model and testing the model, we deploy the model, and then accordingly we hosted the website.
So the algorithm we have implemented is convolution neural networks, which is a part of deep learning, which analyzes images by breaking down into distinct components known as features. So the key part of deep learning is that it deep learning extracts hidden features, which usually machine learning doesn't. So that is why we've used deep learning. So CNN has three layers. One is convolution, pooling, and multi-layer neural network. So these are the results we achieved. We ran about, as you can see from the graph, we have a training and validation accuracy, which gives us 90, is actually 96.7. So this is how our models compares with the other existing models. So our proposed model is in fifth, which of achieving a 99.6 accuracy. So we've used CNN approach because all of the other papers have also used CNN, which gives a high accuracy. So this is the reason why we've used CNN. So our conclusion is, towards the future, our scope is to develop an Android application to get a even more big data set and to achieve a real-time detection analysis. Thank you.
I Deepak, instead of Deepak Mane, Palash was representing, isn't it?
Yes, sir.
Palash, you said about potato leaf detection, isn't it?
Yes, sir.
From where you have taken this data set?
Sir, this data set is actually available on Kaggle, and we also added our own images.
Then how you added that image? From where you have taken the images?
Sir, we've actually found them, sir, a bunch of various websites, but our main data set was picked from Kaggle.
Acha. That is fine. What is about validation? How you means have you taken any help of any expert who is working on that field?
Yes, sir. So Dr. Deepak Mane was actually guiding us throughout this
Deepak
project.
Mane is a guide.
Yes, sir. He's a guide.
I'm saying about expert in biological or that area. Domain. Do you have any domain expert? Palash.
Yes, sir.
Do you have any domain expert? Do you know?
Sir, we haven't particularly interacted or shared this with the domain experts. So,
Acha, one of the step is segmentation in that, isn't it?
yes, sir.
Can you tell me you have done the segmentation?
So segmentation. So in the segmentation, what we have done is we've used multiple layers of CNNs. So sometimes we use two times we've used convolution layers, then we've used the pooling layer to segment various kinds of data which it has detected.
Okay, Paresh. Good presentation. Wish you all the best.
Thank you, sir.
Thank you, sir. Good presentation. So we are moving our closing remarks. I sincerely thank our authors for their excellent presentation and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We, on behalf of whole team, thank you for the support during this ninth version and all the previous 8th version of the conference. We will be happy to have you in the 10th version in 2025. All the presenter would be getting their digital certificates through mail within 2 working days. Further, all the papers are already forwarded to the stranger, and the publication will be live within 6 months. Kindly cooperate with the team of ICT4SD 2024. And I also thank our session chair, uh, Professor Shafi Pathan, for chairing the session. Here is the token of appreciation on behalf of our whole team of ICT4SD and the Global Knowledge Foundation. Thank you, sir, for the valuable presence and information for the authors.
Thank you, Riddhi. If you can give me 1 minute.
Sure, sir. Sure.
First of all, thank you, GR Foundation, for inviting me or for considering my whatever knowledge I have to be shared with you. Thank you. Special thank you to Amit Joshi sir. He's looking after GR Foundation, who is our friend,
Yes, sir.
whom we are in touch. Thank you to Niranjan Day sir also, because he is a connection point between all of us.
Yes, of
Thank you,
course.
thank you to Riddhi. From start to end, she was with in the presentation and coordinated all the things very smoothly and considered every glitch, everything, whatever happens here. Thank you to all the participants, because always it is learning for a person like session chair like me also. At the same time, there were some good presentation. There were some improvement were also required, especially Patil ma'am's presentation, especially Shahruk's presentation on multi-language presentation. Likewise, some good research is there, and in some cases there is a requirement. We frequently talking about, most of the times we are talking about AI and machine learning, but we need to move ahead of maturity of all these things, and conferences are the place where we get to know that what is going on and how that can be taking ahead of it. So thank you all, GR Foundation team. Thank you to my university, MIT Edit University. I am representing MIT Edit University, and because of whom only I could come in front of you as a professor representing my university. So thank you to my university also, and I wish you all good luck to all the participants for their research, and I congratulate GR Foundation for successful completion of this conference.
Thank you.
Thank you and good day.
Thank you so much for your kind words and the suggestion for the authors, sir. So at the last, I request to all please turn on the camera for the quick snapshot of this virtual conference. If possible, please please turn on your camera. Aditya, Vyom, Gauri. Yes, sir. Thank you very much
Thank you
for the,
and bye bye.
yeah. Best of luck for the future work. Bye bye.